Okay, let's make a start. Welcome everyone. Good afternoon or good morning, depending on which end of the increasingly difficult time divide you're on. And welcome to the next in our series of seminars supported by the Strategic Partnership for Implementation of the Paris Agreement, SPIPA, and being co-hosted by the Melbourne Climate Futures and the Melbourne Climate Futures Academy, also known as the Climate and Energy College. It's a delight today to welcome Bjoern Soergel to talk about a broader question than just climate. As one of the things I frequently get asked or mentioned as a climate researcher is a conversation that goes, yes, climate's very important, but, and usually that's a kind of prelude to look over there, but it's also a commentary on just the broader context the climate problems sit in, and one that we, as people working hard on the climate problem, we don't always necessarily give the attention it deserves. So it's really great to have someone thinking about the broader question of human well-being within planetary boundaries, climate being one of the most important of those, but not the only one. So thinking about the integration of response to the climate problem with broader questions of the UN's 2030 agenda and the strategic development goals, these sustainable development goals. Bjoern, who's presenting, has a background in physics, and like many of us, has kind of turned to apply those analytic skills to a range of more environmental and directly people-related problems, and is now working at PIC at the Potsdam Institute, and has been for the last few years, and is one of an increasing but still relatively rare group of people that can think about this very broad suite of problems that have tools and interests that lie beyond just the kind of straight climate research area. So it's a very timely talk indeed, given that we're leading up to a COP where people at the policy level should be at least thinking in this context. We're going to change the way we do things today a little bit, just to note that this is being recorded, but Bjorn's kindly agreed that if people have questions kind of understanding where they're not following what's being presented on the way through, please raise your hand and we'll promote you and get a question asked, and we'll continue the talk from there. It's very common that if one person needs an explanation, several people do. If it looks like it's turning into too much of a comment, we might ask you to postpone that to the end. At the end, we'll do the method we normally have, where if there's a question in the Q&A, this time we won't promote you to panelist because that usually causing problems with video. We'll simply turn on your microphone so you can ask the question. Your camera won't necessarily come up, but you'll be heard, and then we can sort of proceed smoothly on to the next one. And Angela and Kate, as usual, will moderate those. So unless I've forgotten something, I'll turn my video and sound off and hand you over to Bjoern.
Yeah, thanks very much, Peter, for the kind introduction and the invitation. It's my pleasure to speak here today. Hope you can see my slides now. Right, so I'll be talking about how we can bring together human well-being on the one hand with the planetary boundaries, and in particular that means how we can bring together climate policies with a much broader UN agenda for sustainable development. So this is a paper that we published a couple of months ago in Nature Climate Change, and I should also highlight that it's been the result of a huge group effort. So you can see only some of the contributing authors here, Elmar, Isabel, Sebastian, but many others from the Potsdam Institute and also from elsewhere contributed. You can access the paper for free. Unfortunately, it's behind the paywall, but with this link here, you can actually access it for free. Right, and as Peter also said, I'm very happy to be interrupted with questions of understanding so that we can turn this a bit more into an interactive conversation. So if anything is unclear during the presentation, feel free to raise your hand or put a question. Right, so I'm guessing that many of you, if not all of you, will know this photo from the moment the Paris Agreement was finalized, where the world collectively agreed to limit global warming to well below 2 degrees and to pursue efforts towards 1.5 degrees, as the text says. What not everyone is so aware of is that the Paris Agreement also really strongly puts climate action into the context of sustainable development and poverty eradication. If you go through the text of the Paris Agreement, this phrase here, efforts to eradicate poverty, pops up in a couple of places, and similarly for sustainable development. And what's also important, in the very same year, in 2015, when the Paris Agreement was finalized, there was another big agreement, which were the UN Sustainable Development Goals, where all countries essentially agreed on these 17 goals. And one thing that you will notice immediately if you look at them is that climate action is in fact one of these goals. So you have on the one hand the Paris Agreement that highlights the importance of sustainable development together with climate action, and you have on the other hand the Sustainable Development Goals, which explicitly contain climate action. And that is already telling us that we are not looking at two separate, distinct agendas here, but really about one intertwined agenda almost. So the Sustainable Development Goals contain on the one hand a number of what you might call social goals, like the eradication of hunger, reduced inequalities, eradication of poverty, and on the other hand, a number of environmental goals like climate action, of course, biodiversity, both in water and land, and also goals that you might call means of implementation, like institutional quality or partnership. And I think it's really the strength of these Sustainable Development Goals that they bring together these aspects in one unified set of goals. If we look a bit more closely about the interaction between climate change and climate action on the one hand and the rest of this agenda on the other hand, we actually find that there is a huge load of interactions going on. So starting here in the top left corner, both the adverse effects of climate change, but also mitigation costs might interact with poverty eradication. In the worst case, they could even form a poverty trap. Then there's the effect of carbon pricing on how to achieve energy access goals, the effect of land-based mitigation technologies, mostly bioenergy, on food prices because of the competition for crop growing area. There's the effect of fossil fuels on air pollution and the associated health effects, and so on. So I'm not going around the entire square here, just to give you a bit of a flavor that there's really a lot of interactions going on between climate change and climate action on the one hand, and the Sustainable Development Agenda on the other hand. To be a bit more systematic here, in this study from 2 years ago, colleagues looked at all the individual goals. And so the numbers here, 1 to 3 and so on, and the letters are the individual sub-goals or targets that belong to each of the Sustainable Development Goals. And then they went through each of these sub-goals and checked whether this particular target is positively affected or negatively affected by climate action. And they colored it accordingly. And so what you can see from the green colors is that there are a lot of synergies. So that means that climate action will actually positively affect this particular Sustainable Development Goal. There are also trade-offs, as you can see from the orange brownish colors, and essentially for many goals, trade-offs and synergies even coexist within the same goal. So again, that highlights that when we think about climate action and we think about sustainable development, we need to be really, really mindful about these sort of interconnections, because otherwise policies that we pursue for one goal, like climate action, might actually have negative side effects on some other goal. Okay, so after having introduced you to these targets, let's have a quick look at where we actually stand today. So many of you will probably know this great webpage, the Climate Action Tracker. So what they do, and they update that frequently, is that they take the current policies and they project forward to which level of warming that would take us in 2100. And that's what you can see here. If you take the current policies, that's now from May 21, so it doesn't perhaps include the latest developments ahead of the COP, but otherwise it's fairly up to date. current policies would take us to nearly 3 degrees of warming in 2100. If you're a bit more optimistic and you also take into account the pledges, so that means policies that have been announced but not implemented yet, that would take you to 2.4 degrees, but you're still very far away from the aspirational 1.5 degree goal of the Paris Agreement. And you can even take a bit of a broader perspective here, looking not just at climate change, but at a whole set of planetary boundaries. So this is a concept that has become quite important and quite popular when you think about these planetary pressures, trying to define thresholds or upper limits, what is kind of the safe environment for our Earth system, our biodiversity, our biosphere, and so on, for these different categories. And you can see here climate change as one of them. There are many others, like the integrity of the biosphere, freshwater use, the biochemical flows, so mostly the use of phosphorus and nitrogen fertilizer, ocean acidification, and so on. And one thing you can take away here is that for several of these planetary boundaries, we are already in the zone of uncertainty, which means that we are increasing the risk to essentially destabilize these systems that are so important also for our own living on Earth, and for biosphere integrity, and especially the nitrogen flows. We might even have crossed these planetary boundaries, so we're beyond the zone of uncertainty or in the high risk zone. So that was the environmental side. We can also have a look at the social side. So the figure that I'm showing here is from another study that we published earlier this year. So what we did there is to have a look at the relation between socioeconomic development and poverty rates, because the UN Sustainable Development Agenda contains zero poverty in 2030 as the first goal. And when I say poverty here, we're talking really about extreme poverty, which means a poverty threshold, a poverty line of $1.90 per day. And so we took projections for socioeconomic development until 2030 and used those to calculate which fraction of the population would live in extreme poverty, so under this $1.90 per day line, under such socioeconomic development. And what we found is that we would be very far away from meeting this poverty eradication goal in 2030. And I should also say that when we did this calculation, this was still based on pre-COVID numbers. So if you add the effect of COVID on top of here, the situation would look probably even more dire. And again, if you take a bit more of a multidimensional perspective, looking not just at monetary poverty, as we did here on the left, but if you look at decent living standards, this was done by colleagues from YASA in a paper that was also published this year. So they looked at a number of indicators that form a set of decent living. So that's, for example, whether you have access to electricity, whether you have decent shelter, whether you own a minimal set of devices, and so on. And what they found is that there are currently large gaps in this access to decent living standards, for mostly in sub-Saharan Africa, but also in other countries of the global south. And if you project that through to 2030, that many of these gaps will persist. So again, also on the socioeconomic side, the picture is very clear that with current trends, we're very far away from meeting the Sustainable Development Goals. So that we took as an entry point, basically. And what we wanted to do in the study is to develop an understanding of what would be needed to meet both the targets of the Paris Agreement and the Sustainable Development Goals. As we learned relatively quickly during the process, meeting all the goals by 2030 is increasingly challenging, for some maybe even impossible. So we said, at least let's try to develop an understanding how we can make as much progress as possible towards the SDGs by 2030. But of course, the world doesn't stop in 2030. As you can see in this nice illustration here on the left, But it's important that we continue with these sustainable development policies towards 2050 and beyond, and also with the long-term perspective of meeting the targets of the Paris Agreement and to respect the planetary boundaries for the other environmental indicators that I mentioned before. I'd call a target-seeking scenario. We had a very clear picture in mind where we wanted to go with this simulation, and we tried to develop an understanding of how to get there. So, as you maybe know, in this kind of climate and scenario research, we work with a framework that is called the shared socioeconomic pathways. I will just explain that very briefly so that we're all on the same page. These shared socioeconomic pathways are basically a set of assumptions, for example, about population development, about economic development, about technology availability, and many other aspects. And they were harmonized between different modeling groups so that we're essentially all talking about the same thing. So when we tried to work on such a sustainable development pathway, we basically tried to embed this a little bit within this framework. And that's why you will see these SSP abbreviations popping up here on the slide. SSP is shared socioeconomic pathway. So the starting point that we took here is to project current trends and policy actions forward, just to get an understanding of what the gap is between where current policies and trends would take us and where we want to go. And so in this SSP world, SSP2 is a scenario that basically is more or less in line with current trends when it comes to population development, economic development, and so on. And NDC stands for nationally determined contributions. So these are the current relatively weak climate policies. And then we tried to sort of close this gap towards the ambition of the Sustainable Development Goals in a set of interventions. So I'll go through them individually and then I'll unpack them also in a bit more detail later in the presentation. So for the first intervention, we bundled together, or it's actually two interventions that we bundled together. One is about human development, so education, gender equality, economic development, and institutional quality. And the second one that we bundled together with that is resource efficiency. So that gives you a little bit of extra towards the Sustainable Development Goals. Again, in this language of the shared socioeconomic pathways, that would take you from an SSP2 trends continued world to an SSP1 world, which is the most optimistic and most sustainable of these shared socioeconomic pathways. The second important ingredient is, of course, climate policy. As a next step, we added policies compatible with reaching the 1.5-degree goal from the Paris Agreement to our simulation. And this is actually, if you look into many previous studies, this was actually in many studies framed as a sustainable scenario. However, what we did is that we actually quantified where such a world would take us with respect to the Sustainable Development Goals. And we realized that you're very, very far away from the Sustainable Development Goals. And that's why we brought in 3 extra sets of interventions. One relates to food and energy, one relates to global equity, and one relates to equality and poverty alleviation at the national scale. And what we found is that if you bring all these different sets of policy measures together from all these different areas, then you're actually looking towards what you might call a more holistic, more comprehensive sustainable development policy approach that actually really makes substantial progress, taking us from the unsustainable status quo towards the ambition of the Sustainable Development Goals. So I also want to briefly introduce the modeling framework that we're using. It's an integrated assessment modeling framework called Remind and MAGPIE. So integrated assessment model, for those that have never come across these models, means that we basically try to bring together economic development, energy system, agricultural system, the effect of both of these on the climate in one model. And then we typically look for strategies how to best achieve targets like the Paris Agreement climate goals. So in a way, you can think of this as a huge optimization problem where the boundary condition to the optimization is a carbon budget that is compatible with the 1.5 degree target. And then what we're looking for is essentially the best way to meet these targets. So what these models contain is, first of all, on the side of Remind, a macroeconomic core. So that's about economic development, investments, and so on. And of course, energy is a very important part of our economy. And that's why this macroeconomic core is linked to a very detailed representation of the energy system. So that starts from all the primary energy carriers that are available, both fossil and renewable, and then has all the conversion technologies, all the different end-use categories that we have for energy. Some of these energy users, of course, mainly the fossil ones, are associated with emissions, and then these emissions are fed into a climate module. On the other hand, we have MAGPIE, which is a land use model. So here, based on both socioeconomic inputs, like, again, population development and economic development, but also on biophysical constraints like water availability, yield potentials, and so on, land use patterns are derived in this model. And it's important that we actually link these two together. So on the one hand, MAGPIE informs Remind about the emissions from the land use sector. So that's both carbon dioxide from land use change, but also methane and nitrous oxide from agriculture, and the price for bioenergy. And on the other hand, Remind informs MAGPIE about the demand for bioenergy in the energy system and the price on emissions. And then we actually have these two models exchange information in an iterative way until you reach a joint equilibrium, so that it's almost like treating the energy system and the land use system together in a single huge model. And I'm dwelling on this interlinkage because it's really important, because often we find that policies on the energy side will actually have implications also on the land use side, for example, through the demand for bioenergy. So it's really important to not just think about energy or land, but really think about these together. So that's why researchers in our area often also talk about the energy, land, water, climate nexus, so really having a very broad perspective here. Just very briefly, I also want to talk about the resolution of the model and the climate policy settings. So in such complex models that represent the energy system and the land use system in great detail, unfortunately, it's not possible yet to resolve every country individually. So what we do and what other modeling teams from other institutes also do is basically to treat large countries like, for example, the US, India, China, or Japan as individual model regions, and smaller countries are grouped together. For example, all the European countries are together form an EU region here. And the typical climate policy setting that we have is that policies start after 2020 with a period of staged accession. What that means is that high-income countries would actually start with a carbon price that's fairly high and that's really fully in line with the 1.5 degree target. And low-income countries, developing countries, would start with a lower carbon price and only gradually converge to the same carbon price as high-income countries. So there's one part of global equity, or common but differentiated responsibilities, as it's called in the Paris Agreement, already sort of implemented in this climate policy setting. So for this study, however, as we wanted to talk not just about meeting climate targets, but also about the Sustainable Development Goals, we had to broaden our toolbox a bit. So this Remind Magpie framework is still the core, but then we supplemented it with a lot of individual smaller models that speak to different sustainable development goals. So for example, we have an ocean model run by a colleague at PIC. It's in fact not just ocean, but a full Earth system of intermediate complexity that takes up the CO2 emissions from our Remind Magpie framework and then simulates the effect on the Earth system looking mostly towards the ocean, so things like ocean acidification. Then we have a model on air pollution and health. So here in particular, the aerosol emissions, so air pollutants from the energy system are taken up and then translated into health effects like premature mortality or disability-adjusted life years lost. For poverty and inequality, that's a model that I worked on a lot. Here we make an assessment of how climate policies, but also the revenues from carbon pricing and how you can redistribute it would actually change the distribution of income and therefore also the poverty numbers. Then we have some assumptions about burden sharing, so how the efforts to meet climate targets are distributed globally. And we also collaborated with political scientists from the German Development Institute to get an assessment of institutional quality and conflict likelihood along these scenarios. And that's also something fairly new that hasn't been tried before in such a scenario framework. So the goal that we had here really was to quantify indicators from the Sustainable Development Goals, or at least to find meaningful proxies that could speak to these SDGs. And I think we succeeded in that so that we can say something about all these 17 SDGs. So I'm demonstrating this now here by throwing a lot of figures together at you. No worries, I'm not going to talk about all of these individually. There's just a couple of points that I wanted to highlight here. So first of all, in the figures that I'm going to show you, we concentrated on 1 or 2 indicators per SDG, so that we have a set of around 20-ish indicators here, and we call these the headline indicators. These are the ones that we give most attention to also in the paper. But if you're interested in a much broader perspective, I invite you also to look into the supplementary information that we published together with the paper, because there we look at an even broader set of, I think, 56 indicators in total. So here we group these indicators into 5 thematic clusters. One is planetary integrity, so that relates to climate, water and land biodiversity. We have provision of material needs, so this is about basically food, energy and water provision. We have people, so this is poverty eradication, education and health, prosperity, economic development, inequality, livable cities and so on. And then this cluster on institutions, peace and partnership. And so for all of these goals and within these clusters, we actually managed to find sensible representations for this in our modeling framework. And I just wanted to highlight that there's also a few in here that previous studies haven't really looked at so much. So I've mentioned ocean acidification already. We have a quantification of biodiversity intactness in our model, a projection of how many people would live in extreme poverty, about disability-adjusted life years lost from air pollution, and as I said already, from these institutional quality indicators. So let's come back to these interventions. Interventions in this setting you can understand as policies or measures that would take us from the current unsustainable status quo to the future we want to go, which is set by the Paris Agreement targets and the Sustainable Development Goals. And so I just want to briefly unpack what we have in these interventions. What are the kind of policy actions? There's one subtlety here. This probably speaks more to those of you who've dealt with these kind of models before. So there's a couple of things that relate more to input assumptions of the models. There's a couple of things that relate really fully to the modeling dynamics as they are. And in some cases, we also have policies implemented as a constraint in the model. So I use these slightly cryptic abbreviations to tell you how these different interventions, policy measures are actually represented in the model if you're interested in the details. Otherwise, I'm not going to dwell on this too much, but you can also ask me about this in the questions if you're interested in the details. So let's come back to the content of these interventions, starting with food. So it's been known for a while that also our diets are really a key determinant for climate and sustainability questions. So there's been the study by a commission formed together from people studying our nutrition, looking at what kind of nutrition is actually best for our human health. And they brought these researchers together with sustainability scientists in this Eat Lancet Commission. And this Eat Lancet Commission then came up with a recommendation for healthy diets, so motivated from our human health, but that have also positive implications for our planetary health. And what we assumed here in this calculation is that there's a gradual shift towards these healthy and sustainable diets according to the Eat Lancet recommendations, which means above all a reduction of animal protein. And besides that, we also put it really as a cornerstone that the goal of zero hunger would have to be met in these simulations by 2050. That's not 2030 as you would like in the Sustainable Development Goals, because we found that this is really very difficult to impossible to reach, but at least that it would be met by 2050. On the energy side, you can also work out that there is a minimum requirement of energy consumption to enable these decent living standards that I talked about before. And again, we wanted that as a kind of boundary condition that in developing regions, at least this kind of minimal level of energy demand is satisfied. On the other hand, in high income regions, we have more almost a problem with overconsumption of energy. So that's why we also made the assumption that through a combination of both efficiency and sufficiency measures, you can actually reduce energy consumption in high income regions quite a bit. And then there's a lot of individual policies in here that relate to energy and land system sustainabilities. There's, for example, an accelerated phase out of coal power plants, a limit on bioenergy with carbon capture and storage. That's this BECCS abbreviation, and a protection of biodiversity hotspots. I should maybe just briefly explain about BECCS or BECCS. So that's a technology, or a postulated technology, I should say, that would allow to take carbon dioxide out of the atmosphere by first growing energy plants, then either turning them into liquid fuels or burning them in a power plant and sequestering the CO2 that is emitted and storing it underground. So if that works, then you can generate energy while at the same time taking carbon dioxide out of the atmosphere. But there's a lot of reasons to be a bit skeptical about this technology, at least at large scale. The main one perhaps being that to generate relevant amounts of energy from this technology, you would need huge amounts of land area for growing energy crops. And then, of course, you get into trouble with growing food because you can't do that on the same area. And that's why a limitation to this bioenergy with carbon capture and storage technology is actually an important sustainability policy for the model. Right, so let's have a look at some results. And I'm going to show a couple of these figures to you. So let me first of all explain sort of in a generic way how to read the figures and then come back to the content. So I'm always showing one specific sustainable development indicator here. In this case, the number of people underweight. So that's a quantification of the risk of hunger. The first bar is the status quo in 2015. The second bar is if you follow through with these trends, current trends that we have at the moment and the current policy actions. And the red step is showing you the difference that these current trends would make between 2015 and 2030. And then the 3 steps in yellow, green, and blue are first of all these human development interventions, secondly, climate policies, and then thirdly, these extra sustainable development policies that I'm sort of introducing as we go along here. On the left-hand side, this number of people underweight, this mostly relates to an assumption that we made, so that hunger would be eradicated by 2050, and that means by 2030, you're on the way of doing so. That's why this blue step here goes down so much. On the right-hand side, you can see a result that comes out of the model, the food price index. And what you can see here by looking at the green and the blue step is that, in fact, climate policies have a trade-off related to food prices. For example, through growing bioenergy crops, you would make food more expensive if you just do naive climate policy, so to say. However, if you combine climate policy with these additional sustainability policies, in this case, it's mostly the transition to healthier and sustainable diets, then you can actually completely compensate this food price trade-off, and your food prices remain at pretty much the same level as without climate policy. And this is really an example of how combining climate policy with other policies can resolve trade-offs. And that's a theme that will come up over and over again during the rest of the presentation. Besides food prices, these land and food related sustainability policies actually have huge implications also for many other environmental dimensions. So here I'm looking at a number of planetary boundary related indicators in 2050, which is first of all the agricultural water use, the nitrogen fixation, so nitrogen fertilizer use, and the biodiversity intactness. And these horizontal dashed lines here are target values for the individual indicators that we inferred from the planetary boundaries. And what you can see again is that these land-related sustainability policies and the dietary changes actually reduce agricultural water use so that you are again below or within the planetary boundary. They drastically reduce nitrogen fertilizer requirements so that you almost make it to the planetary boundary, and they improve biodiversity so that again you almost meet the planetary boundary related target. And that, I think, is really one of the core insights from our study, that the co-benefits, so the additional positive side effects of a transition to healthy and sustainable nutrition are really huge. And this relates not only to climate, but really to essentially all environmental dimensions that we looked at. Let's move on to energy. So on the left here, what this abbreviation stands for is the useful energy for buildings and mobility in lower income countries. So essentially that's a proxy for access to modern energy services in the global south. And again, this here on the left relates more to assumptions that we made when setting up the model, so that there's actually an increase in energy use, or in this useful energy, so in energy service access in the global south. And on the right-hand side, this relates again to a result and the energy prices. So the green step going upwards is again a trade-off associated with climate policy, and this is making energy more expensive. However, again, if you combine climate policies with these extra sustainable development policies, then you can compensate at least roughly half of this trade-off. And here I'm looking at 2030, where this kind of trade-off is most pronounced. If you look towards later years, then the trade-off with energy prices is smaller already, because then you're already in a sustainable, renewable-based energy system, and then it can perhaps even be fully compensated. So again, what's important here is that we bring together, on the one hand, energy access policies in low-income regions, and on the other hand, a reduction of energy consumption in high-income regions. And with that, we can at least partially compensate the trade-off of increasing energy prices due to climate policy. Let's move forward to the last set of interventions, which relate to inequality and poverty. And one of them, global equity, takes the international perspective, and the other one takes the national perspective. So what we suggest here with respect to the international perspective is that you could take part of the carbon pricing revenues that come with the climate policy and redistribute them internationally in terms of a climate and development finance. So as some of you will know, there is a commitment by high-income countries to international climate finance to the order of $100 billion per year. So far, unfortunately, this commitment hasn't been fulfilled. So what we propose here is that you can actually finance these policies from the carbon pricing revenues, or at least you take part of the carbon pricing revenues for this international climate policies, international climate finance. And also we call it climate and development finance, with the idea that this is not just for climate policies in the global south, but really to, again, take this broader perspective of also supporting sustainable development policies like poverty eradication, and perhaps also infrastructure financing for other sustainable development goals. The second intervention here is the counterpart on the national side, where the carbon pricing revenues, including those potential international transfers for the countries of the global south, are redistributed as an equal per capita climate dividend. So what that means is that all the carbon pricing revenues are collected, and then each citizen of the respective country receives the same amount, for example, as an annual check from the government. And there are many studies already saying that if you do that, then climate policies are actually pro-poor, because poor households tend to have a much lower carbon footprint than high-income households. So what that means is that at the end of the year, they get back more in terms of this climate dividend, this check from the government, that they paid in terms of carbon pricing in the first place. And that's, again, how you can combine, on the one hand, climate policies with progressive policies like a reduction of inequality or poverty eradication. So looking at the results on the left-hand side here, I'm showing the relative poverty rate that is defined as the fraction of the population of a given country that is below 50% of the median income of that country. And the numbers that I'm showing here are the global average of that relative poverty rate. And again, you can see from the figures that there's a trade-off associated with naive climate policies. They would slightly increase this indicator of inequality. However, if you bring in these extra compensation and redistribution policies, you would substantially decrease inequality, and way more than compensating this trade-off of climate policy. And on the right-hand side, I'm looking at an absolute indicator of poverty. So this is, again, the $1.90 per day threshold that I mentioned before. And you can see that there is, again, a positive side effect of these additional sustainable development policies, so that you can more than compensate the trade-off associated with climate policies and actually combine climate policies with poverty reduction. So let's take a step back, going from the individual interventions to the big picture. So what we try to construct here, you might call an SDG index. So each line here in this figure corresponds, again, to one sustainable development goal. I hope you can see it. Probably the icons are a bit small, but we're starting from SDG 1, zero poverty here, and going all the way through to SDG 16 for institutional quality and peace. We didn't put SDG 17 on here because there is no quantified target for SDG 17 that we could use. So the way to read this plot here is that 0 corresponds to the status quo in 2015 when the Sustainable Development Goals and the Paris Agreement were finalized, and 100% would mean that you have completely achieved the target at a global level, either in 2030 on the left-hand side of the figure or in 2050 on the right-hand side of the figure. And the red bars here are, again, this continuation of current trends in relatively weak climate policies, and the blue bars are our complete sustainable development policy scenario. So bringing together climate policies and all these extra sustainability policies that I just explained. And there's a couple of things to take away here. First of all, if you compare the blue and the red bars for each indicator, so for each line in this plot, you can see that you can really substantially improve essentially in all categories over just a continuation of current trends. So what that means is that all these extra policies do have a substantial effect in improving outcomes towards essentially all of the Sustainable Development Goals. However, the second important thing to take away is if you compare where the blue bars end up compared to this 100% line, is that you see that many Sustainable Development Goals are extremely difficult to reach by 2030. And this is because of the now relatively short time horizon. There's only 9 years left, and also a lot of inertia in many of the systems that we're looking at here. However, to be more optimistic, if you look to 2050, then you can actually see that if you continue through with these sustainable development policies, then many of the targets that you could not meet by 2030 will in fact be met by 2050. We were also able to do such an assessment at the regional level. So again, these are the 12 model regions that we use in our modeling framework. And there's a lot going on in this figure, so let me try to unpack this a little bit. So I mentioned before that we grouped the Sustainable Development Goals into these 5 clusters: planet, provision of material needs. So that's, for example, food security and energy access. There's people, so this is poverty eradication, health, education, gender equality. There's prosperity, so this is, for example, inequality reduction, and institutional quality here. And then I further subdivided each of these circles into segments, and each segment stands for one SDG. And the color coding of the segments matches the color coding of the SDG icons. So that, for example, here, this bright blue stands for SDG 6. So if you look at this bright blue segment, you can learn something about SDG 6, which is water. And then how filled the segments are actually tells you something about the progress towards the SDGs in this optimistic sustainable development scenario by 2030. So I don't want to dig too much into the details here. Let me maybe just extract 1 or 2 main insights from this figure. If you look at the high income regions like the EU or the US, what you typically find is that they perform quite well or very well on the social side of the Agenda 2030. So, for example, poverty eradication, health provision, education, but they have problems on the environmental side, for example, due to still high use of nitrogen fertilizer. On the other hand, if you look more towards the low-income regions like Sub-Saharan Africa, India, Southeast Asia, then you will see that they tend to have gaps more on the social side of the Agenda 2030, like poverty eradication again, but they tend to perform much better on the environmental side. So what this is highlighting is that even in this very optimistic world with a lot of sustainability policies, no single country or region will have fully made it by 2030, but all countries or regions need further development along certain directions, with the high income countries mostly having to reduce their environmental footprint and the low-income countries catching up on the more social side, like poverty eradication. We also did the same assessment for 2050. So I'm going to try to flick between the slides. I hope this comes through also in the shared screen version. So what you can see when I flick between the slides is that between 2030 and 2050, many of the segments that were previously partially white fill up a bit more. And that is what you could also see on the previous index slide, that if you further pursue these sustainable development policies, also after 2030, then you can close many of the remaining gaps until 2050. So with this, let me try to wrap things up. So what we've shown in this analysis is that development policies, resource efficiency, and sort of moderate lifestyle change and climate policies are in fact not sufficient if you compare the results of these policies to the ambition of the Sustainable Development Goals that all countries agree to. And that's why in this analysis, we identified a number of additional intervention areas. One relates to global cooperation. This is this climate and development scheme that I introduced. National redistributive policies, so where you take the revenues from carbon pricing and redistribute them within each country. And in fact, both of these are some kind of policy linking approach, where you don't think about environmental and social policy separately, but you recognize that there's an interlinkage and that you can take revenues from pricing carbon dioxide emissions and other greenhouse gases to compensate for compensating policies and for redistribution policies. And that really brings together the environmental and the social policy side. And on the food and energy side, I think really the most striking result is how big the co-benefits of healthy and sustainable diets are for climate, land, water, the nitrogen cycle, biodiversity, and so on. So really across the whole range of environmental targets that we looked at, changing diets has a large positive effect. So if you throw all of this together, then you can really make substantial improvements towards nearly all SDGs. However, there will be gaps remaining in 2030. The time horizon is just too short. And that, of course, applies even more if you take into account the effects of the pandemic as well, which will have detrimental effects on meeting many of the Sustainable Development Goals. On the other hand, if you look towards a longer time horizon to 2050, then what we find is that, in fact, many or most of the Sustainable Development Goals can be met. But to be very clear here, what we did was really essentially pulling all levers here. So we started from the targets and we wanted to understand what can we still do to meet the targets. So many of these policies that are introduced during the presentation are really, really ambitious. So in that sense, you shouldn't read this as a projection for a future world until under standard policies as we have it now, but you should really see this as an exercise of, if there's the political will to really from now on go all in for the Paris targets and for the Sustainable Development Goals, this is how far we can go, and these are the key policies that we need to go there. So I'll stop here, and I look forward also to your questions and to discussing with you. Thanks very much.
Great. Thank you very much indeed. That was a fantastic talk. And I would like to say at least mildly optimistic, the idea that I've been in the climate business long enough to remember when research was showing that there weren't necessarily feasible paths to get us to reasonable climate goals. So the idea that there might be, and that a range of the other SDGs might be kind of at least feasible, if not at all straightforward, simultaneously, is a useful story to take away. I won't monopolize any more of the time because we don't have a lot. But I'll hand over to Angela and Kate to handle moderation of potential questions.
Thanks, Peter. So we've had 2 questions so far, and I'm going to ask the second first on behalf of Alan. So on the energy intervention slide, why is the price of renewable energy increasing rather than decreasing?
Right, let me just go back to the slide again. And I'm just going to share the screen with the slide again. So I assume this is referring to this one here going upwards. So what we're showing here is not just the renewable energy price, but the average energy price, which, because we're looking at 2030, will still include some degree of fossil energy. So we're seeing a couple of effects here. First of all, there's a carbon price, which makes all fossil energy carriers more expensive. And then in 2030, you're still very much in the transition phase where you're switching, or you have to switch from a fossil dominated energy system to a renewable dominated energy system. And that switch requires a lot of investment. So that switch doesn't come for free. However, in the long run, renewable energy, once you're through that transition, will be cheaper than fossil energy. Already now we're seeing that in many locations, solar PV or wind are much cheaper than fossil energy. So the uptick in cost that we're seeing here is related mostly to this transition phase.
Great, thank you. The other question we had was from Ben, who unfortunately looks to have departed, but his question was on food. Sustainable development policies are critical. You mentioned that this is mostly reduced animal protein. How much reduction have you assumed, and does the whole globe have to become vegetarian?
Yeah, that's a great question. The Eat Lancet recommendations, it's not a fully vegetarian diet. It's one that reduces substantially, especially on red meat, but still contains some, although much reduced amount of meat consumption and of fish and also of dairy. So it's not a fully vegetarian or even vegan diet, but it is one that makes drastic reductions in animal proteins. And we assume that this doesn't happen overnight, but gradually, so that there's a transition phase from now until 2050. And over these 30-ish years, there's a gradual shift from the current dietary patterns to these healthy and sustainable dietary patterns.
Great, thank you. We've also had a question come through in the chat. Did you use any software for the simulation models?
Yeah, so that's a model that we develop in-house at the Potsdam Institute. The model itself is programmed in GAMS. Probably many of you have never heard of this programming language before. It's a language that is specifically designed for these kind of large optimization problems. So that's what the core model is built in, programmed in. And then we have a whole set of routines for data preparation, for output processing, which is in R, which is a more standard open source programming language. So in short, that means we didn't use any sort of pre-packaged software where you can click together such kind of simulations. Such a thing doesn't really exist, but it's really programmed in programming languages.
Thank you. So that question was from Maria, and sorry, Maria, I jumped the gun in asking that for you. We've got one more question here from Michelle. So Michelle, I'll pop your mic on so that you can ask yours directly. It's a bit of a longer question.
Yes. I was just wondering whether the research also takes into account the influence of the voluntary carbon markets in terms of their influence on movement towards the SDGs, or is it mainly just focused on the compliance markets? And so then, sorry, I had a follow up to that. And then if it does also account for the voluntary carbon markets, what's the sort of scale of that influence?
So by voluntary carbon markets, you mean country A paying country B to do some sort of reduction, which is then attributed to the carbon balance sheet of country A?
And more in terms of corporates who don't have any, so like outside the EU, well, example being Australia, we have climate active carbon neutral certification. So that's companies making headway towards being like reducing their emissions and taking action on climate, but it's not a compulsory or compliance market, so they don't actually have to do anything. So a lot of them do prefer to target like emissions reductions outside of their own activities, beyond starting with their own activities. But for those that they can't reduce themselves, they prefer to target carbon credits with co-benefits.
Right. Okay. So now, thanks for clarifying. You're talking more about companies. So that we don't have included because that goes beyond the granularity that our model can resolve. So basically, our model treats countries or regions as one agent, and this agent sees a carbon price and therefore decides to reduce emissions. But of course, you can argue that implicitly somehow this might still be covered to some extent, because what a carbon price means that if you can reduce emissions at a price lower than the carbon price, say the carbon price is $200 per ton, and you can reduce emissions in your own company for $100 per ton, then you would rather do that than pay $200 for that ton. But then you could, of course, also make the choice if reducing emissions in your own enterprise is more expensive, that you look towards funding reductions elsewhere. But of course, that's always to be taken with a grain of salt as these sorts of offsets generally, because you need to ask questions like, are these offsets that are funded, are they actually additional emission reductions that wouldn't have happened without this project? Are they actually long-term persistent? So for example, for afforestation, you need to ask the question whether that forest will stand for long enough to actually really absorb all the carbon dioxide that it's budgeted for, and so on. So I think in general, although we don't model that explicitly, my opinion is that these offsetting things should always be taken a bit with a grain of salt, and you need to look carefully whether it really delivers on the promises.
Cheers.
If there's time, one more question has come through from an anonymous attendee, which was asking how political differences inside each region were measured, so mainly towards policy effects on poverty levels and access to sustainable sources by low-income sectors. We might make that the last question in interest of time.
Thanks. Great question. That really goes to the heart of the exercise. For inequality and poverty, we were actually to resolve this at the subnational level. So the way I did this, I first went from the sort of coarser model regions, which in many cases comprise multiple countries, did a downscaling to country level. And then in each country, I actually simulated how climate policies and also the redistribution of the carbon pricing revenues affect the distribution of income. And that's how I calculated all these inequality and poverty indicators that I showed to you. For food and energy, I would very much like to do the same, but there we are not quite there yet. So ideally, you would also work with distributions of energy consumption and with distributions of food consumption within each country, but that's something that is still under development.
Okay, I think that's probably all we have time for. First, thanks very much to everyone for coming, and a great series of questions showing people were really engaged. And thanks particularly to Bjoern. That's kind of, as I was hoping at the start, a way of situating what happens in the climate space in the much broader kind of policy agendas that any real policymakers, right, have to keep before them. Like any piece of work, exploring this space, it raises as many questions as it answers. That's the task of a piece of research like this. But if I was to take away one point, the idea that there are feasible pathways through, and that some interventions that might promote well-being individually as well as collectively, like changes in diet, are things that we could probably sell to the world. These are probably not only feasible, but saleable ideas that we could actually convince large enough numbers of people to take up. So thanks very much to everyone, and look forward to the announcements for the next seminar. November's a busy month. We don't stop for the COP, so we'll be running seminars right throughout November. So keep your eyes out on email for invitations for those.
Yeah, thanks very much also from my end. It's been my pleasure to present to you, and thanks for all the great questions.